Welcome everyone. This slideshow presentation will introduce you to the serious side of old car restoration. Restoring the bodywork of an AC 2-litre saloon is not for the faint-hearted. With its internal ash frame, this sort of work is usually left to the expertise of specialist coach builders. Yet very few take on this task on this model of AC. That's because of its low market value. Years ago, the AC factory would refuse to restore these cars, and experienced professional car restorers will also avoid timber-framed cars. To take it on as an amateur in a single garage takes a special kind of optimist, or maybe a crazy person. Make your decision after the video. Firstly, to assess the problems. The timber may be afflicted with wet rot, dry rot and/or woodworm. Animal glue is used, and this has very little water resistance. It also attracts woodworm, especially the plywood parts. Water ingress also turns the plywood into a pack of cards, metaphorically speaking. The next problem is that the factory engineering drawings were destroyed in a fire at AC Cars Limited some decades ago. The good news is that I have created new drawings. And the next challenge is that the wood is partly covered up by the panelling, making it hard to identify defects, let alone repair them. If you strip out the interior trim and remove the inner body panels, you gain access to the majority of the woodwork. But there were some areas where I could have missed woodworm damage had I not removed the shell. Most of the wood screws were inserted from the outside and are covered by the shell. Some of the large plywood sections cannot be installed when the body shell is in place, unless modifications are made that might weaken the structure. The rear shelf is a piece of plywood that is integral with the structure, which is built around it. It is just possible to slide a new one in when the shell is removed. The two large boot side panels were not designed to be installed into the part-assembled car, but it might be possible to fit panels with the top part cut off. Then make a separate part for the top, which will need a strong joint. The main body shell was not originally installed as a single piece. It was prefabricated as at least 5 sections, then fitted over the wood frame and gas welded together in situ. This left scorch marks on the timber. Contrary to popular opinion, the wood won't burst into flames if you place a lighted match near it. That only happens in old Warner Brothers cartoons. As to what happened with my AC, in the 1980s I did a partial restoration when I was a teenager, but later realised that the underlying condition was worse than it seemed. I got out a library book on restoring wood frame cars, and then formulated a plan which I'll now go through step by step. This took place in 1991 when I was young, optimistic and still wearing short trousers. To my knowledge, nobody had ever removed the shell from one of these saloons before. Some open-top ACs, such as Bucklands, have had similar in-depth restorations done. I spent 3 weeks stripping out the interior trim and removing the wings, inner rear wings, etc. I also had to remove the aluminium gutter ring. Unfortunately, these were nailed on, and the nails are recessed with no access for tools. I had to prise the gutters off, distorting it and hoping that I can straighten out the damage later. The body shell edges are mostly folded over the wood frame and fixed with small panel pins. Needless to say, these pins were rusty and reluctant to come out. I levered up the panel edges, often leaving the rusty pins behind. Some of the panel edges had to be unfolded. This was around the rear wheel arches and the rear side windows. To a lesser extent also the rear windows. Modern technical articles on repairing aluminium car bodywork sound paranoid about bending the metal with the risk of work hardening and cracking. The duralumin alloy on the AC seems to cope with some bending back and forth before failure. However, my plan was to anneal the edges before the shell goes back on. With the sill panelling freed from the frame, I tied rope around them so that they don't catch on the doorway when I rolled the car in and out of the garage. And yes, this did happen once. The less said about that the better. Another mistake concerns the rear panelling, where there are 2 thin strips running horizontally. The welds at each end are prone to cracking, although there were no visible cracks before I removed my shell. The cracking usually occurs when the glue joints fail in the wood, or the wood rots away, which allows any body twist to overstress certain points on the rear panelling. My mistake was not to reinforce this area before lifting the shell off, as 2 small cracks and 1 large crack appeared. With the shell freed from the frame, I propped it up an inch or 2 ready for lifting. I managed to do this with the help of just one other person, but I would recommend having 4 people. There's a high risk of damage. We lifted it into my garage, rested the rear on a pair of spare wheels, and then propped it up with a wooden frame I had made earlier. We then turned the car around and it just managed to squeeze in underneath. My garage is 7.5 feet tall. That was the easy part. Knowing that the factory drawings were destroyed, they had been called for many years for someone to make new ones, assuming that anyone happened to have an undressed AC to hand. This was a chance in a lifetime, so I grabbed my pencil, sketch pad and a tape measure and got to work. That may have been my next big mistake. I had to make sure that the car was not twisted and that the leaf springs were settled. Then I had to find reference lines and make straight edges to measure from. As you can see, most of the car shape is compound curves. Some of the joints were obscured and I needed to do some partial dismantling to examine them. This was long before I had CAD programs, let alone high-tech measuring devices, and it turned into a nightmare lasting 6 years. There were about 9,000 dimensions to measure, cross-check, etc., and it was easy to make mistakes. For reasons not worth going into, I shelved the whole Resto project and then got sidetracked by other interests, businesses, etc. Fast forward to 2006 and Woodworm were taking over. They completely destroyed the original plywood bulkhead and were getting to work on other plywood sections and some of the ash. Also the temporary frame holding up the body shell. They had also invaded my small workshop, attacking 2 benches, some tool handles and stocks of spare timber. It took several weeks to get the invasion under control and 2 years to be certain it was eradicated. I coated the wood with cuprinol woodworm killer several times and also sprayed an aerosol version into the holes. It sprays back out of adjacent holes, so be careful. You can see that the frame looked a bit dark at this stage. I had applied clear varnish to protect it. In the UK, most woodworm is due to furniture beetles. They lay their eggs on bare unpainted wood. When they hatch, they bore into the wood and happily turn it into a fragile honeycomb over a period of a few years. The wood can seem solid on the outside but almost completely destroyed internally. In 2009 I finally got back to the restoration. I started by making some wooden jigs to guard against losing critical dimensions. The large jig across the B pillars proved to be unnecessary because they are reinforced with steel pillars and the condition was not too bad. The jig for the rear made allowance for the fact that the rear shelf area had sagged slightly and needed to be lifted about 1mm. A lot of rusty panel pins had to be extracted, although the worst ones broke off. Firstly, I needed some wood. The plywood needs to be birch, which is even stronger than oak and ash. Make sure it is birch throughout and not some sneaky cheap stuff with birch only on the outer layers. After seeing how disastrous the original animal glue was, it is essential to get plywood with exterior grade adhesive. This is a formaldehyde based adhesive which has a distinctive dark reddish brown colour. When my 3 sheets of ply arrived, I noticed that the middle sheet did not have this dark glue line. I got the supplier to swap it for the correct material. For the ash timber, it is best to find a supplier of air-dried ash rather than the cheaper kiln-dried. AC also used a lot of beech, which is just as strong. It is more prone to splitting when hammering in panel pins, so it is worth drilling pilot holes for these in beech. AC also used a bit of mahogany, which is not as strong, so I would not recommend fitting any new pieces. Now at last the wood frame resto can begin. I started by making new boot side panels from 12mm or 1/2 inch birch ply. When cutting it, the surface splinters badly and it is best to use a fine saw blade. At first I shaped the axle cutout like the later version of this panel. Then I decided to change it to the original shape for this AC. The enlarged cutout was for the original lever arm damper, but this AC received a factory upgrade in 1960 to telescopic dampers. It is handy to have this larger hole for easy access to the inner bodywork when working on the car. On the downside, it lets in more water and mud, but you can add a removable screen. The right hand panel has to clear the fuel filler pipe. The bottom edge bolts to the chassis. There are also small bolts for the boot floor. With these side panels in place, helping to support the frame, I got to work repairing the bottom rear corners. There is always the dilemma over whether you should cut out a large volume of original sound material to give a simple strong repair, or retain more original material, creating a more complex repair. On these curves, it can help to have repair pieces that keep the wood grain in the ideal direction for maximum strength. But then you have to be sure that the new joints are strong enough. There is often debate over whether to glue, screw, or glue and screw. They originally combined glue and screws, and for good reasons. Screws without glue permits flexing, which might crack the panels. It also allows water into the joint, starting the problem all over again. The decision on the size and number of screws are based upon engineering data I found online from the timber industry. It largely follows the original coach builder's practice for screw strength. The joints should be more than strong enough with the screws alone, just in case the adhesive fails. The adhesive I used was formerly called Aerodux 500, developed at Duxford for aircraft. It's now called Prefer 4050. It's a formaldehyde-based adhesive. I purchased mine from a UK company that supplies materials for building gliders called Seven Valley Sailplanes. It is also used for boats since it has the best resistance to moisture, especially where there is intermittent wet and dry conditions. Epoxy is ideal for constantly wet conditions. The drawback of Aerodux type glues is that you have to clamp the joint tightly while it sets. Epoxy can be better for joints that can't be clamped. Getting back to the finer details of the timber repair, it is much harder than it looks to get a perfect fit. The shapes are too complex to rely on making templates. Present day technology might speed things up with 3D scanning and printing. I kept the AC in the garage most of the time to be sure it was not twisted. That meant many long work shifts of up to 6 or 7 hours crouched on the floor craning my neck. My neck isn't so good now. As you can see, this part of the wheel arch is a complex shape. I used a rasp for much of the shaping and then smoothed off with a file. True coach builders might frown at this technique, but it gets the job done okay. With the jig in place, the original shape of the boot was retained. I repaired the ends of the rear cross member. This often needs to be completely renewed on ACs. At this joint there is a rainwater drainage hole. Needless to say, these two rusty coach bolts had to be renewed. There's the doorstop refitted for the spare wheel compartment door. You can also see the lock slot for the budget type door lock, which had also rotted a little. You need to be thorough about removing all traces of rot. If wood feels hard and firm on the surface, it does not automatically mean disassembled. Pressing the tip of a wood chisel against it, you will usually show any weaknesses. The surface might sink if there is rot underneath. If there are woodworm holes, you need to find out if the internal damage is extensive. Woodworm are fussy about which timber they munch through, so sometimes there is a hole or two where they have passed through. If there are many holes, then the inside is probably a disaster area. I renewed most of these little corner pieces. Then I moved to the hinge rail. Then some minor repairs further up. These two small curved rails had both split along a short grain, so I reinforced them. I test fitted the boot lid and rear wings. I was disappointed to see how many large gaps had been left in some joints from the original build, so I was careful to make all joints tight and strong. It was always nerve-wracking doing the final gluing, as once it is fixed, it's fixed. That was always the cue for one of the local pensioners to come over, block the light, and lean against parts that aren't fixed on properly. Oh, for a big private garage. Some folks still think I'd restore a car for fun. I quickly painted the rear of the frame to protect it from woodworm. I used an aluminium base primer followed by 1 part polyurethane. I renewed one of these blocks and repaired the other one. I barely got started on the wood frame repairs and I'm tired out just talking about it. Part 2 will take us further into the wooden adventure. Thanks for watching.